Hi everybody, I'm Dr. Huseynova and I welcome you again on my channel eye-Dr.Tuti. Today I will continue the topic corneal physiology, and this is the second part of this topic. Let me just briefly remind you that in the first part I talked about the physiology of corneal epithelium, about the maintenance of corneal epithelium and the wound healing of corneal epithelium. Today in the second part I will continue with physiology of Bowman's membrane and stroma. The main characteristics of Bowman's layer that it's a modified region of anterior stroma. The anterior surface of this layer is smooth and the collagen fibers are synthesized and secreted by stromal keratocytes. The thickness of this layer is approximately between 8 to 14 micrometers. This is a cellular homogeneous zone and there is no fibroblast. Therefore, after injury, it's unable to regenerate. And this layer is being replaced by a coarse scar tissue after injury. The main function of this layer is that it provides anchoring site for epithelial cells in order to ensure stability. It's a tough acellular layer and at the same time provides mechanical support. This layer additionally prevents stromal keratocytes from exposure to epithelial growth factors and also prevents keratocytes metaplasia to fibroblasts and scar formation. Let me now continue with stromal physiology. As you remember maybe from my previous presentation, cornea as a refractive medium, this is the slide from that presentation where I briefly talked about each layer of the cornea. So I have this slide also there where I describe the stromal structure. So we know already that this structure stromal structure made up of 200-250 lamellars of collagen fibers. And the lamellars, they formed of bundles of collagen fibers. They stretch from limbus to limbus. And around the limbus, at the periphery, they run circumferentially. And by this, they form annulus, the width of which is about 1.5 to 2 millimeters. And this provides the curvature of the cornea. And this has a profound implication for possible alterations of stromal structure during refractive or cataract surgery. And this may lead to possible refractive errors. In this slide, you can see a picture where you can see collagen fibers, proteoglycans, and now we're going to continue with proteoglycans. Proteoglycans, it's a ground substance of the stroma, and there are two main types of proteoglycans. The first type is chondroitin sulfate dermatan sulfate proteoglycan and keratan sulfate. Decorin is the only chondroitin sulfate dermatan sulfate proteoglycan in the cornea, and it's more abundant in the anterior part of the cornea than in the posterior. Keratan sulfate proteoglycan, it's more abundant in the posterior stroma, and there are three types of this proteoglycan: lumican, keratocan, and mimican. Lumican is responsible for corneal transparency. Lumican, keratocan, and mimican are also found in another tissue, but only in the cornea they present in a highly sulfated form. The main function of this proteoglycan is that they confer hydrophilic properties of stroma. They play a very important role in corneal transparency, and they help in regular spacing of collagen fibers in order to ensure transparency. And this shows that proteoglycans and collagen fibers, they have a specific interaction in order to keep this transparency of the cornea. Keratocytes. Keratocytes is a cellular component of the corneal stroma, and normally they turn over every 2 to 3 days. They synthesize collagen. The cells are activated when the stroma is damaged. They differentiate into fibroblasts during wound healing, and there is a gap junction between cells. Corneal transparency and stromal function. This slide was also at the presentation cornea as a refractive medium, so I just wanted to add these slides in this presentation too, because it just clearly describes the corneal transparency and stromal function. So interwoven fibrous collagen, they provide mechanical strength of the stroma and the cornea itself. The regular arrangement of collagen, they provide transparency of this tissue. Additionally, there are some specific factors which play a very important role of maintenance of corneal transparency. The fibers of the stroma, they have regular diameter, interfibrillar distance less than a wavelength of light, avascularity of cornea, as we know already that cornea has no vessels, and relative dehydration. In this slide, and in general, as I said already, as I mentioned just a few slides before, then there is a special interaction between proteoglycans and collagens in the stroma. And once this interaction between proteoglycans and collagens of the stroma is damaged or just somehow prevented, then clinically we can see abnormal picture of cornea. For example, granular dystrophy is an autodominant disorder in which microfibrillar deposits lead to corneal opacification, and this process is thought to reflect altered phospholipid metabolism. Another example is lattice dystrophy. Lattice dystrophy is stromal disorder that results from the localized accumulation of amyloid. And the last example is macular type 1 dystrophy. It appears due to abnormal keratin sulfate synthesis. In this type of dystrophy, the cornea synthesizes the lactosaminoglycan proteoglycan rather than keratin sulfate. And this abnormal keratin sulfate is localized in stroma but have no association with collagen. Stromal wound healing. This slide and this scheme actually shows, from my point of view, perfectly the stromal wound healing. As we can see here, keratocytes, they proliferate and migrate into fibroblasts, and then they proliferate into myofibroblasts. So this is the normal process, and as I said already, the normal turnover of keratocytes takes 2 to 3 days. And then after myofibroblast proliferation, there are two ways, physiological and pathological. Physiologically, this process ends up with apoptosis, and pathologically, when the stromal tissue is damaged, it ends up with haze or any scar tissue formation. And keratocytes activation, as you can see, again, leads to cell migration and transformation into fibroblasts, and this leads to production of scar tissue in case when the stroma is damaged. This was the physiology of stroma and Bowman's layer, and we're going to continue with the third part of corneal physiology presentation, where I will talk about the cement membrane and endothelium. Thank you for watching this video. I hope this video was informative for you. Keep yourself updated with my next part of this presentation. I'm wishing you a good day. Bye.